Okay, let's get started. So far we've taken a look at translations, which just means sliding around, movements, not doing anything other than shifting left, right, up, and down. Then we looked at reflections, which changed our orientation, reversed our orientation because we reflected or flipped it over a given line. And today we're going to take a look at rotations. So rotations are our spins. So we're going to spin it around a fixed point. So let's take a look. So essentially what we need to know is that rotations preserve distance, angles, and orientation. So just like translations, when we rotate, our figure does not change at all. The distance between the two corresponding pieces remains the same. Nothing changes there. And angles remain the same. Orientation goes VWU, VWU, same direction. So in this case, clockwise. So when you get a second, go ahead and take a look at this. This just gives you a summary of what's going on with your angles of rotation. We also know that a rotation point is, about a point is a rigid motion. So it's an isometry. Nothing changes. Isometry. Okay, so we are going to practice these. They're not the easiest ones to do, so it's going to take some practice and some little bit of coordination. You need a compass and a protractor with you. If you don't have it right now, pause the video and go get one because you need one to do this project. So unless otherwise stated, rotations are always counterclockwise. So we are going that direction when we measure angles. So let's take a look. What is the image of lowercase r sub 100 comma c of triangle LOB? So let's talk some notation. This lowercase r indicates rotation. So our uppercase r from yesterday dealt with a reflection. Lowercase r means rotation. This is your angle of rotation. And this designation right here is your center of rotation, meaning that is the fixed point on which everything else spins around. So we're going to call it center of rotation. So just like yesterday's line of reflection stayed put and we flipped stuff over that line of reflection, today we're going to look at rotations. This is my fixed point. And this point does not change. Everything spins around it. Sometimes your center of rotation is outside the triangle, and sometimes it'll be a point on the triangle. So let's take a look. Step 1. It says below to draw the segment CO. So what you want to do is from center of rotation to a vertex. So it doesn't matter which one, we're going to start with O. You're going to draw in that segment in dash. So you're going to dash it in. That segment does not become part of your new rotated figure. It is there to help us get some angle measures. So we're going to dash it in. So if you have 3 different colors of pencil, that tends to help as well. Regular pencil works as well too. You just have to pay attention to what's going on. So I'm going to use 3 different colors so we can see it. So I'm going to draw in from the center of rotation to one of the vertexes. What I'm trying to do is get a 100 degree, this is our angle of rotation, 100 degree measure. So I need 2 sides to do that. So I need to rotate my paper so that I can get my 100 degrees. Because we're going clockwise, you're going to set your protractor with the point in the middle. The line lines up on top of the dashed line that you just drew. And you're going to have it so that the center of rotation points to your triangle. So that you want the 100 degrees on this side, not up top here. So you're going to look for 100. Since we're going this way, this is where my line goes, I need to use this inside bar. So I'm going to follow this around until I'm about 100. I'm just going to make a little mark. so that I know from this point to this point I'm going to get an angle that's 100 degrees. Again, none of this is used to make my new triangle side, so I'm going to dash it in. It just gives me the rotation point where I know my new prime vertex is on. So this becomes 100 degrees. Okay, so we just found our 100 degrees. What we need to do is get this point that we just created this 100-degree angle for onto here. Since I preserve distances, I need to take my compass from the point, the center of rotation, and open it to the original vertex point. So I know that the point O is this far away from the point of rotation. So that means I can go over here and make a little mark on my new line that's going to tell me where the point is, so that this distance is the same as this distance. This crossing over point is my O prime. That was steps 1 to find my 108 degrees. Steps 2, use a compass to construct C O prime the same or congruent length as CO. So we opened our compass to this section made a little mark here so that we knew how far away from the thing. Then we're just gonna repeat. So this is a repeat from the same other thing. So I'm gonna switch colors, and we're going to do, let's do L. I take from the point of rotation to the vertex that I'm trying to rotate across, and I draw in my hash. From that point on the right side, that means I need to rotate my paper so that I can line up my dash line with this line right here on my protractor. And I am going to the right, so I start at 0 and mark my way around to 100. I'm going to make a little mark so I know where to put the other ray for my 100-degree angle. I'm going to drop that in so I know that I just made a 100-degree angle for my O prime, or my L prime. So the last step then is to figure out, okay, this distance along this red line needs to be the same along this red line. So I take my compass, I open it up to the distance from C to L, and I go mark that on my red line so that I know that those two segments will be congruent. So I mark my L prime. So I've got 2 of the points. I just need to do the third. I'm going to switch colors so we can see it. I go from the center of rotation to the vertex. Flip my protractor over so that I can make a 100-degree given angle. I swirl up here. That's 100 about right there. I draw in that ray. I find the length using my compass. The distance from the point of rotation to the vertex is that wide. So I go up here and I mark it on my green line. That becomes my B prime. So all that's left to do is, now that I've done each of these 3, I ignore all these lines. I don't need them anymore. I just need to connect my prime vertices. I have a prime there and a prime there. I have a prime there and a prime there. So let's just create that triangle. I end up with a rotation that looks like so. Okay, so pause the video, go back through it if you need to understand the process. It takes some time, so don't get frustrated. Work your best through this lecture, and then we can work on this some more in class. Okay, so let's take a look at one more example. So we are going to do example 2. In this case, it says to draw a 150-degree rotation of triangle ABC about P. So P is my center of rotation. So if I were to write this in function notation, I would say R is 150 sub 150 P of triangle ABC. So you may also see it like that. So again, same steps apply. I find my center of rotation and I draw a point, draw a dashed line to each vertex. I'll start with A. In this case, I want 150 degrees, so I want to make sure that my point of rotation is in the middle of my protractor and the side is to the right. I'm going to go 150, which is clear over here. So I mark it clear over there. I dash in that line as well. That whole angle is now 150 degrees. So you should be able to stop and think, okay, that whole angle, that's good. I was drawn up to A, so that means I need the same distance from the center of rotation to the vertex as to A prime. So we are going to open and close our compass so that it's the same length. Then I just move my compass over here so that I can find where that goes. So I mark that A prime. Repeat the process with your other vertices. I'm going to go to B this time. You can go in any order, doesn't matter. And I get this dashed line. From the vertex or the center of rotation to the vertex needs to be on the right side of my protractor. I go through and I find 150. So over here. Then I'm going to line up to make the other ray of my angle. That gave me my 150 degrees right there. I need from the center of rotation to the vertex to be the same distance, so I take my compass and open it to that same length and find that length on the new ray. Where that little mark intersects is my new B prime. Okay, one more. We're going to do C, and that's the last of our triangle. I dash it up. I line it up so that that first segment is to the right. I spin around to 150. And I connect to make the other ray of my 150 degree angle. My distance from the center of rotation to the vertex has to be same. So I open my compass. I take my compass and I mark that same without changing my compass. Mark that same position over here. That's my C prime. So I've done each of the vertices. Now I can just connect my prime vertices together for my new rotated figure. Angle B was a right angle, so we can reality check it and make sure that's still a right angle. And that becomes my rotated figure. Okay, so pause the video, try the next one, and that is the answer you should get when you get done. And then we'll take a look at example 3. Okay, let's do example 3. Previous 2 examples that we worked on in your practice on was a rotation point or a center of rotation that was outside the original figure. If we take a look at example 3, it says what is the image of triangle LOB for a 50 degree rotation? So I have a rotation 50 degrees about B. B in this case is part of the original triangle. So we're going to rotate it about B. That means B stays put. This is my rotation point. The steps are all the same, only this time I only have to do it for these 2 because we already know where B is. B is on the rotation, so B is also going to be B prime. Just like on our reflections, if our point is on the line of reflection, it is both the pre-image and the image point. So I need to do the same exact things I did with the previous triangles. I need to go from the center of rotation to one of the vertices and drop in a dashed line. Eventually you can skip this dashed line step. From there, I put my protractor on the center of rotation with the dashed line to the right, and I find my degree angle. So it said 50 degrees, so we're going to come up on the inside to 50. From the center of rotation, I create my second dashed line. The next step was to find out how far O is from the center of rotation and mark that on the dashed line, and that becomes my new O prime. We do the same exact thing as we were doing before. So we go from the center of rotation, what happens to be on my triangle, make a dashed line to the other vertex. From there, I make sure I line up my protractor with the center of rotation and the dashed line to the right. I go up, I find 50, and then I put my second dashed line in, so that I have my second 50-degree angle. I need the center of rotation to be the same distance as it was from in the original figure, so I'm going to open my compass so that it's the same distance and make a mark on my dash. Where I made the mark becomes my L prime. I now have B prime, O prime, and L prime, so I can connect my rotated figure. Once you make your connection, you're going to highlight your image to indicate it is your final figure. Okay, you should pause the video now, try the one below, and see how you do. Come back and check your answer. Okay, there's the answer to your practice problem. If yours does not look like this, try again. Redraw your triangle over here and try it again. See if you can get there. If you're still struggling with it, make sure you put a big fat star or circle so that you can come into class ready to ask questions when I see you tomorrow. All right, last concept. This makes it actually easy when we have specific rules. So let's take a look. So what we have is when a figure is rotated by a set amount, there's this cool little rules that come into place that deal with vertexes and a unit circle. So these specific rotation values in a coordinate plane allow us to map our x and y's in a given order. So we could still go graph our original figure and do the same thing with our compass and our protractor that we've been doing. But what helps is this mapping for this specific value of rotation makes our life a lot easier. So we've got one for 90 degrees, we've got one for 180 degrees, this one's for 270, and this is for 360. Well, if I rotate a figure around 360, where am I going to end up being? So 360 is all the way around. So I'm going to end up right back where my image and my pre-image are the same figure. So let's talk real quickly about what this means. This original is an XY coordinate. That means I took my Y, put it over here, and changed its sign. I left my X the way it is, but turned it into my new Y. 180, I have an X and a Y. All I do is change the signs, flip the signs for the X and Y. When I have 270, I again switch my places for X and Y, but I need to flip the sign for the X, so my new Y gets the opposite sign. And 360, I just end up back where I was, so I just leave it. So let's try one of these. So it says graph quadrilateral KLMN. Here's my vertices. Then rotate it 270. Well, 270 is a mapping. I'm going to change these to X and Y. XY to, if we look at our 270 up here, Y comma negative X. Y comma negative X. Okay, so that's my new mapping. So I can take each of my points and use this map to figure out where my prime points are. So this says to make the Y without any changes the new X. So I'm going to take my what used to be Y and put it in the X position. So my new prime becomes a 2 for the X. This becomes a 2 for L. Negative 3, because I don't change the sign of my Y, I just move it into the X position. and -1. This says to take your x, make it in the position of y, but change the sign. So this, what the x used to be 3, I'm going to make it -3. -4. Used to be 4, becomes -4. 2 used to be 2, so it becomes a -2 in the y position. So practice your mapping. And then it just becomes about graphing them. So a lot easier than having to use your protractor and stuff. So we need to graph our original. K is 3, 2. 1, 2, 3, 1, 2. There's K. L is 4, 2. 1, 2, 3, 4, 1, 2. M is 1, 2, 3, 4, -3. 1, 2, 3. That's M. And N is 2, 1, 2, -1. That's N. So I'm going to either use a straight edge or carefully connect my points for my pre-image figure. The mapping makes it easy to do my image because the points are already here. 2, -3. 1, 2, 1, 2, 3. That becomes K prime. L prime is 2, 1, 2, 1, 2, 3, 4, -4. That is my L prime. -3, -4. 1, 2, 3, 1, 2, 3, 4. That is M prime. And N is -1, -2. So -1, -2 should be my N prime. When I connect those figures, I should have a congruent figure with the original pre-image. So they should not change shape. They were just rotated around the origin. So the origin became my fixed point. And let's highlight in our image. Okay, so if your shape is different, that means something happened with your points and you need to fix it. So I should end up having the same distance here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this length is the same as this length, so on and so forth. So nothing should change. Okay, the last page is 3 for you to practice. You will see that on the last page, number 2, that should say 180 up here, not 100, not 90. So make sure you notice that that says 180 because you're reflectioning on it as a 180. So you're going to use your mapping rules and then try out the last 3. All right, so pause your video, do the last page, see where we get. Alrighty, you should have gotten figures that look like this. Let me zoom out. I went through, I showed my original points, then I showed my prime points, original prime, went through, graphed each of the points. So your figure should end up looking like that. If you did not get these, pause the video, try and see if you can figure out where your mistake was. So we should have the same exact congruent figures each time. So we'll practice these more in class. Don't panic. Let me know if you have any questions when I see you tomorrow.